So in this video we're going to do Eulers Method again, but this time you're going to see it's a one that I don't know how to separate. You know, it's dy dx is y minus 2x. That's not a differential equation that I can separate and integrate. So Eulers Method is really our only way of estimating at this point. So I'm going to make my table, x and y, dy dx is equal to y minus 2x, delta x. And remember, that has to be given to us, so that's 0.5 all the way down. Delta y is equal to dy dx multiplied by delta x, just like a tangent line. And then the last thing is the new point. You know, x moved by how much, and y moved by how much. Okay, so the first point they give us is 0, 1. So dy dx is y minus 2x. So in our case, that's going to be 1 minus 2 times 0. You can write that for the first time here at least. So that's 1. So delta y is equal to dy dx multiplied by delta x. That's 0.5. So x plus delta x, well, 0 plus 0.5 is 0.5. And y plus delta y, so 1 plus 0.5 is 1.5. So that becomes our new point. So then 1.5 minus 2 times 0.5 is 0.5. Remember, delta x is the same all the way down. Well, 0.5 multiplied by 0.5 is 0.25. So x, 0.5 plus delta x, 0.5 is 1. Y was 1.5 plus delta y is 1.75. That becomes our new point. Okay. So we've got now y minus 2 times x. So this becomes negative 0.25. Delta x is the same. 0.5 multiplied by negative 0.25 is negative 0.125. So this is 1.5. And 1.75 plus negative 0.25 is 1.625. And that becomes our new point. So we do that minus 1.625 minus 2 times 1.5, and we get negative 0.13, it's negative 1.375. This stays the same. Multiplied by 0.5, we get negative 0.6875. So we're now at 2. We get only a couple more steps to go. We're at 0.9375. So this one's a little bit different in that it went up and then it's coming back down. And again, that just has to do with what the slope field would look like. Okay, so 0.9375 minus 2 times 2, so negative 3.0625. This continues to be 0.5. So this is negative 1.53125. So 2 plus 0.5 is 2.5. I may have to start rounding here. 0.9375 plus that value, 0.59375. That becomes our new value. We got one more round to go. So y minus 2x, so minus 2 times 2.5, this is negative 5. 0.59375. This is 0.5. So 3, and we add negative 0.59375 and negative 2.79, we get negative 3.391 if we round. So this is what Eulers' method would estimate the value of y of 3 is based on that differential equation. Now real quick, I just wanted to explain kind of what happened on that and explain why, we started by going up and then all of a sudden it went down. This is the slope field for y minus 2x. So we start off with a value of 0, 1, which is right in here. So you can see that the slopes are going up and then they start going down and then they really go down in a hurry. Okay, and we were trying to estimate a point down in here, so you can see that based on the shape, the shape of the function must do something like this or like this, depending what that initial value is. You can see that it does start going up and then go down really, really quickly as you go on. And I should be drawing these more like that. So it makes sense that slope field gave the answer it did, because that's correct. The original function must decrease very, very quickly.